Before moving on to the next examples, I think it will be actually really helpful if we just go through and remind ourselves what the sets of numbers are. Now I'm going to go from the smallest to the biggest sets. This one right here, this one in the middle right here is going to be the natural numbers. Which we use the letter N to describe, and it includes 1, 2, 3, etc. So it's not going to be anything negative, and it's the number system starting at 1. Then we branch out using this Venn diagram. So we're talking about this set right here is a subset of actually the universal set, and is a subset of the next group, which are whole numbers. Which we use W to describe, and this is 0, 1, 2, etc. Okay, all the way up to, infinity, which is not a number, it's just a concept. Come and talk to me about that later. So we have all of the elements in the natural numbers contained in whole numbers. The only thing that's different is that the whole numbers have 0. The next set up are integers. So we use the letter Z to describe that. And what this is, it's all negative numbers. So from negative infinity, -3, -2, -1. It also includes 0, 1, 2, 3, etc. So it includes everything that's a whole number plus all of the negative numbers. The next one is rational. Not only do they can do rational numbers, which we use capital R with two, kind of like two tall backs. Not only does it include all of the negative and positive integers, not only does it hold all of the whole numbers and all the natural numbers, it's basically anything that can be, so any number, not hashtag, any number that can be expressed as a fraction. So that's any repeating decimals, so 0.3333 or 0.3 repeating, 4/9, -7/2, -1.5, like anything that can be expressed as a fraction. And the number, I actually made a mistake here, folks, if you can just erase that. The rational numbers, they're Q with an extra little boom, okay? Because the actual thing that uses this is the real numbers. I totally forgot that for a second. So this is anything that you can imagine. Okay, any repeating decimal or decimal that doesn't repeat, or any number like pi or phi or anything. Okay, this right here is the universal set. The only thing that does not live in the real numbers is something called the square root of -1, which we have described as I. Okay, so this is not real. It's actually called the imaginary number system, which I will maybe say for another day. Maybe you don't want your brain to hurt like that, but imaginary numbers, they're not real. Oh, I crack myself up. Now these right here are all, this is the largest set here, the rational numbers, and they have subsets. Okay, the rational numbers have subsets that are integers, whole numbers, and natural numbers. Now this is an example of a disjoint set. You see that there is no touching between this larger circle and this smaller circle. This is irrational number. So this could be described as pi or phi, which is the golden ratio, which is a number that goes on forever. Or we can say negative 7.3621589. There's no pattern here. Okay, it just keeps on going forever and ever, just like pi. So going over these helps us in two ways. It helps us remind ourselves of Venn diagrams, which is going to be a very important tool for you for the rest of this unit. But it also reminds us of all the different types of numbers that we can describe. And we will be describing using set notation.